Okay, so the last thing we need to look at in terms of probability before your exam is something which is called conditional probability. So conditional probability means you get given a probability question and then we give you some extra information, which means that we're going to change the denominator of the probability from there. So conditional probability is extra information given to you about the chosen outcome. Now, the words we use for this are given that, and the symbol we use is just a straight line up and down. So we're going to start with this with a really simple question. The only way I can show you this is really by doing lots of examples. So for example, the sort of basic probability question of I roll a fair die, 6-sided. Okay, I roll a fair die. So we've done this before. Our sample space is 1, 2, 3, 4, 5, and 6. Now, if we look at questions from this and we just say probability of rolling a 2, you quite easily say, great, it's 1 over 6. However, if I give you some more information, so if I told you that the answer is even, your sample space is going to change. I'm telling you your answer's even. So 3 of these results now are definitely not right. Okay, it's even. And so if I then say what's the probability of rolling a 2, the question says what's the probability of rolling a 2 given that it's even. And so my denominator now changes. It's not 6 anymore. There's only 3 outcomes in the sample space, and one of them is a 2. So it's 1 over 3. So that question there says the probability of rolling a 2 given that the outcome is even. So you might also ask something like this. I'll just get rid of that. And often, once again, prime numbers come up in exams a lot. So we might then say, what's the probability of rolling a 3 given that the answer is prime? So this time I'll just highlight the ones we're going to look at. We need to know the prime numbers, so 2, 3, and 5. Of those, how many prime numbers are there? We do our denominator first. There's 3. How many of them are the number 3? Just 1 again. So we need to look at what those outcomes are and change them as we go. All right, so the steps for this is looking at your sample space, given extra information, change, or check, I guess. So we'll say change the denominator to reflect the new sample space. And then it's the same things for the numerator, so it's just the chosen outcomes, just as normal, from the new sample space. Alright, so let's have a look at a question quickly. So, if we did an example of I roll a fair die and flip a coin. So I'm going to do my results for this in a table, because a table is a good sort of sample space as well. So I've got 1, 2, 3, 4, 5, and 6 is the outcome of the rolling a fair die. And then I've also got flipping a coin, so I've got heads and tails. So our actual sample space are the letters and numbers I'm drawing in black. So heads 1, and so on. And then tails. Alright, so from there we then can answer some questions. So the first one I might just say, what's the probability of a 3? And so from there you look at it, there's 2 answers which have a 3 in it out of 12. But our answer changes when I say, what's the probability of getting a 3, given that my answer is heads. So at this point we need to go, okay, how many of the outcomes have heads in them? And there's 6. So our denominator changes from 12 to 6 because we know it's none of the answers with tails. And so it changes to 6. And how many of them have a 3? Just the one, so it's 1 over 6. The other sort of question you might get asked with this is putting a bit more information in as well. So you might get asked something like, what's the probability of rolling a, let's say, odd number, given that heads or 5. So this is saying it's either heads or a 5 in our answer. So I've been told it's either a heads or a 5, which means it could be heads, it could be a 5, or it could be heads and 5. I'll just erase that quickly. Okay, so what that means is we're now looking at a different sample space. So we're looking at heads. So all the heads, I probably just could have left them, all the heads and the 5. Okay, now I know there's one which has heads and 5, only counts as one outcome though. So our new sample space has 7 outcomes, and of them, 1, 3 and the 2 5s are odd, so it's 4 over 7. It's really about knowing how to get your new sample space first. All right, we'll try one quickly with a Venn diagram. So I'm just going to make up a question. So I'm going to say A and B, 8, 12, 3, and 7, which makes 30 in the corner here. All right, so from here, we might say probability of B, given that it's in A. This means we know that it's in A. So our sample space changes from being a total of 30 to being a total of 20. And within that, it says, so this is where our sample space comes from. How many of those are in B? So our answer there is 12. So our probability of being in B, given that they're in A, is 12 over 20. All right, we'll try another one. So probability of A, given that it's not in B. So again, I highlight what's not in B. This is our denominator. What's not in B? We've got everything outside plus the A only. So we end up with 8 plus 7, which is 15. Of those, how many are in A? Just 8. So find the denominator first, do the given that first, then find the numerator. So it's not too hard. All right, the only way to do this is to practice. So your homework is on page 53. There's quite a lot. 53 to 56 of your 2C book. Page 53 to 56. Questions. You can go straight through, I reckon. Questions 1 to 15. There's quite a lot there, but you haven't got too many notes to write. That's it for probability. We're going to keep going after your exams with tree diagrams and simulations, but that's where your exam goes up to. So two-row tables, Venn diagrams, all types of probability and conditional probability you should be able to do. Good luck and keep working, please.